Page 3 is where we are going to start those questions that we struggled with on the last test. So it says answer the following questions about the function, then sketch its graph. Again, this is a no graphing calculator question. It's a no graphing calculator test. So the degree of this function, degree always deals with the number of x's that are getting multiplied together. So there's one x here. For here, there's actually 3 x's. This is an x cubed, so that would count for 3 x's. And then this last one is technically an x squared, so that would count for 2. So 1 plus 3 plus 2 tells us that the degree is 6. Leading coefficient, I'm just specifically asking, is it positive or negative? In this case, it's negative because that's all that matters. The number doesn't matter, just the if it's positive or negative, the sign. The 6th degree and the leading coefficient tell us the end behavior. Okay, even degree tells us that it's opening together on the ends, either both up or both down. Negative tells us that it's both down. So as x goes to positive infinity, our f of x is going to negative infinity. And as x goes to negative infinity, our f of x is also going to negative infinity. The x-intercepts in multiplicity, we just need to set all of the different factors equal to 0. So we have negative 2x as a factor, x plus 3 cubed is a factor, and x minus 2 squared is a factor. All right, so that negative 2x equal to 0 tells us x is 0. So this is x equals 0. Its multiplicity is the degree that the x is raised to. In this case, the degree that x is raised to is 1. For the next one, you have x plus 3 equal to 0. So subtract 3, you get x equals negative 3. So x equals negative 3 is the next x, and that has a multiplicity of 3. And then the last one is x equals 2 with a multiplicity of 2. Y-intercept, you just plug in 0 into the equation. So negative 2 times 0, that's going to be 0 plus 3 cubed, and 0 minus 2 squared. Negative 2 times 0 is just 0. 0 plus 3 is 3 cubed. 0 minus 2 is minus 2 squared. So that's 0 times 27 times 4. Notice this is just 0 times all of this, so then we should just get 0 for the y-intercept. But that should make sense because we have an x-intercept at 0 as well. So 0, 0 is the y-intercept, and you should always write the y-intercept as a point. So then let's graph everything we have. We have that we're going through 0, 0. We're going through negative 3, which would be right here. And we're going through positive 2. We know that we're opening down and down based off of our end behavior that we built. Okay, so that means we're going to start down here, and we're going to go up. We specifically, at negative 3, should form a cubic as we go through the function. At positive 2, this is a bounce, so we should bounce there. So then let's draw that. So we're going through here, cubic function, and then we come down through the 0, and then we just bounce down. And then there's our function. All right. On to factoring and solving. So, looking at number 6, we have a perfect cube and a perfect cube separated by a subtraction sign. This is a difference of cubes question. So, difference of cubes means we need to find an a value and a b value. You find that by taking the cube root of both of these things. If you don't remember how to do that on a calculator, it's just up caret and then parentheses 1 divided by 3. Raising something to the 1/3 power is the same as cube rooting it. So that tells us that the a value is x, b value in this case is 4, and then we just fill it in from there. So same sign first, x minus 4, and then it's a squared, so x squared, and then opposite sign would be plus, and then ab, which would be 4x, and then the last sign is always positive, and then it's b squared, so 16. Solve these for x. The first one's easy, x equals 4, right? The second term, though, not nearly as easy. You have to use quadratic formula here. Quadratic formula has x equal to the opposite of b, so negative 4, plus or minus the square root of b squared, which would be 4 squared, minus 4 times a, which is 1, times c, which is 16. All of this is divided by 2 times a, which would just be 2 times 1. Okay. I'm going to skip some simplifying steps here. This is going to give us negative 4 plus or minus, and then you would get the square root of negative 48 over 2. Negative 48 reduces to I, radical 16, and radical 3. Radical 16 is 4. So we get negative 4 plus or minus 4I radical 3 over 2. Because 2 comes out of all three of these, we can divide each of them by 2 to get negative 2 plus or minus 2I radical 3. And there would be our other two solutions. Alrighty, this next one. So if you're ever the case where it's not set equal to 0, you have to make sure it's set equal to 0. It's always helpful to have your biggest power positive. So I'm going to move the x and move the 4 to the other side. So that's 5x cubed plus 20x squared plus x plus 4 is equal to 0. 4 terms always means factor by grouping. So you're going to pull out a 5x squared here. That's going to give you x plus 4. We need x plus 4 in the back, which it already exists. So this is literally just plus 1 times x plus 4. Okay, because 1 times x plus 4 does not change x plus 4. You can factor a 1 out of x plus 4, and again, nothing changes. So that gives us our factors, 5x squared plus 1 multiplied by x plus 4. Again, right side is not bad. This is just x equals negative 4. And then we need to figure out the left side. So for that, I'm going to change my colors. 5x squared plus 1 is equal to 0. Subtract 1 is 5x squared equals negative 1. Divide by 5. Whoa, what happened there? Oh, it just disappeared. Sorry about that, guys. 5x squared plus 1 equals 0. So we had 5x squared equals negative 1. Divide by 5 gives us x squared is equal to negative 1/5. Square root, you get x is equal to plus or minus I square root of 1/5. Which, if you got there, I probably wouldn't take off any points. But I kind of like simplifying the square root here. You would multiply by square root 5 over square root 5 to get x is equal to plus or minus I radical 5 over positive 5. And that would be your best answer. Remember, to get a radical out of the bottom, you just multiply by the radical in the bottom. Okay. Next up, number 8. Again, got to move everything to one side. So 3x to the 4th plus 5x squared minus 12 is equal to 0. This is 3 terms, okay? So it's going to break up into our normal factoring. We have negative 12 on the end, 5x in the middle. 3 and 4 sounds kind of nice. If we went positive 3, that would give us 9. If we subtracted 4, that would give us positive 5x squared in the middle, right? So neither of these factor further. This is not a difference of squares, right? 3 is not a perfect square, so it's not a difference of squares. So we just solve from here. 3x squared minus 4 equals 0. X squared plus 3 equals 0. So that's x equals plus or minus I radical 3. On this left side, we add the 4. So that's 3x squared equals 4. Divide by 3. So that is, move up here, x squared equals 4/3. Square root both sides. You get x is equal to plus or minus. Square root 4 is 2 over the square root of 3. And then you multiply by square root of 3 over square root of 3 to get x is equal to plus or minus 2 radical 3 over 3. All right. So I know those radicals are a little bit tedious, okay, but make sure you're at least attempting to simplify them as much as possible, guys. All right. Okay, number 9, perfect cube, sum. So this is the sum of perfect cubes. So we have an a value that is 3x. We have a b value that is 2. Remember, just cube root this whole thing. So that tells us 3x plus 2 multiplied by, and then a squared would be 9x squared. You have to square this whole thing. All right, so that's 9x squared. A times b is going to be minus 6x because you go opposite sign for soap, and then always positive would be 4. So that gives us x equals negative 2/3. All righty. When you're plugging this into the quadratic formula, you're going to have x equals the opposite of b, which is 6, plus or minus the square root of b squared, which is 36, minus 4 times 9 times 4, a times c, all over 2 times 9. All right. I'm not going to have us bear through all of the simplifying for this one. You should get it down to 1 plus or minus I radical 3 over 3. Okay. If you need to see that simplifying, just message me in Canvas, and I can help you out with that. Alrighty. Let's take a look at this next one. This one, we have greatest common factor that can come out of both of these things. Specifically, it's 4 and then an x cubed. When you pull out the 4x cubed, you're left with x to the 4th power in the front, minus 16, and then that's it. And that's equal to 0. So this is a difference of squares. So we have 4x cubed, we have x squared plus 4, and x squared minus 4. Difference of squares always breaks up into same factors, just different signs in the middle. This broke into another difference of squares. So if we were completely factoring, we have 4x cubed times x squared plus 4 times x plus 2, x minus 2. And that makes solving these a little bit easier. So this 4x cubed is just going to be x equals 0. X squared plus 4 is x equals, that's going to be plus or minus. You would subtract the 4, so that would make it negative. So there's an I, and then there's a 2, right? Square root of 4 is just 2, so we can say 2i. And then x equals negative 2, x equals positive 2. There's all of the solutions. And last but not least, we have 11, okay? So this is 3 terms. Again, just going to break up into x squared and x squared. We have a plus and a minus because it's negative at the end. 72 is 9 and 8, so positive 9. Negative 8 would give us our solution. X squared plus 9 is going to become x equals square root of 9 is 3. It's going to be square root of negative 9 when we subtract the 9 over. So that's plus or minus 3i. On the other side, we would have x squared equals 8. So the square root of 8 is going to be square root 4 square root 2. So that's 2 radical 2. So then our other solution is x equals plus or minus 2 radical 2. And there are the 4 solutions for that question. Okay, that's all the factoring and solving, and then a multiplicity question, and we'll move on to page 4.